We've long believed that the first people to set foot on the Bahama Islands were the Lucayans, peaceful, sea-loving Arawakan speakers who arrived from Cuba or Hispaniola around 1,000 years ago. But what if that story skips an entire chapter of history? What if ancient seafarers came thousands of years earlier, leaving behind little more than scattered bones and stone tools? Now, for the first time, ancient DNA is shedding light on this mystery, and the results are surprising. Before we start, I'm on a road to get 1,000 subscribers as a small channel. If you want to help me, please subscribe. Let's dive into a forgotten layer of Bahamian prehistory. The Bahamas stretch across the Atlantic like stepping stones from the shores of Florida to the tip of Cuba. These low-lying coral and limestone islands were once larger and more connected during the last ice age, when sea levels were much lower. As waters rose, they became more isolated, turning into scattered oases for marine life, and possibly for early human travelers. For decades, archaeologists believed that the first true settlers of the Bahamas were the Lucayans, part of the Arawakan-speaking Taino culture who sailed in around 1100 AD. These people brought cassava agriculture, polished red ceramics, and fishing technologies that linked them to the Greater Antilles. But a few puzzling clues never fit the narrative. Stone tools that didn't match Lucayan styles, hearths buried beneath village sites, and radiocarbon dates pointing to much earlier visits, all hinted at something older. Still, without bodies or DNA, these clues remained frustratingly silent. That silence is finally breaking. Recovering DNA from tropical islands like the Bahamas is notoriously difficult. The climate is warm, the soil is acidic, and bones decay quickly, especially near beaches where salt spray accelerates the breakdown of organic material. For years it seemed impossible to extract usable genetic data from the region's few human remains. But recent advances have changed that. A technique called hybridization capture uses synthetic probes to isolate and pull out specific fragments of DNA, especially from the dense inner core of teeth or the petrous portion of the skull. Scientists now target SNPs, or single nucleotide polymorphisms, to create genetic fingerprints even from degraded samples. These SNPs allow researchers to compare ancient individuals to modern and prehistoric populations across the Americas. In the Bahamas, a small but powerful set of ancient DNA samples has emerged, each one carefully extracted from long-forgotten burial sites. And as those sequences came into focus, they told a story no one expected. For years, archaeologists working in the Bahamas found subtle signs of a deeper past, hints that someone had walked these islands long before the Lucayan settlements. On islands like Eleuthera, Abaco, and Andros, cave systems and sinkholes revealed layers of charcoal, shell middens, and stone tools that didn't quite fit the later ceramic styles. In some places, these tools were simple flaked chert blades, not the polished artifacts associated with Arawakan farmers. Radiocarbon dating placed some of these contexts at over 3,000 years old, far earlier than any known Lucayan site. Burial evidence was rare but not absent. In submerged caves and dry inland sinkholes, archaeologists uncovered scattered human remains with no signs of pottery or farming nearby. These fragments were all the more intriguing for what they lacked: no evidence of cassava processing, no painted pottery, no village mounds. Just the bones, the tools, and the question: who were these early islanders? When scientists analyzed the DNA from these early Bahamian remains, they expected to find lineages similar to the Lucayan Taino or other Arawakan-speaking peoples of the Greater Antilles. Instead, they found something unexpected. Using principal components analysis, or PCA, the genomes didn't fall neatly into known Taino clusters. Instead, they aligned more closely with ancient archaic populations, early seafaring groups with roots possibly in northern South America, coastal Central America, or even pre-Arawak populations from Cuba. These early individuals showed no trace of the later Lucayan genetic signature, suggesting a completely separate origin. One sample in particular bore striking similarities to an ancient individual from north-central Cuba, dating to over 3,500 years ago, hinting at a forgotten migration route through the Caribbean's northern edge. This wasn't simply early Lucayans arriving ahead of schedule, it was a different people altogether, whose presence in the Bahamas had remained invisible until the genome made it impossible to ignore. The genetic evidence now points clearly to two separate settlement events in the Bahama Islands. The first occurred sometime between 4,500 and 3,000 years ago, likely by archaic hunter-gatherers who used small boats to navigate the shallow waters of the Bahama Bank. These people lived by fishing, shell gathering, and perhaps short-term seasonal camping. Their tools were basic, and their presence was light, leaving behind little more than hearths and blades. Then, around 900 to 1100 AD, a second population arrived, the Lucayan Taino. These were skilled agriculturalists, ceramic producers, and village builders. Their DNA, material culture, and oral histories connect them firmly to the Arawakan world of Cuba and Hispaniola. But these later arrivals were not direct descendants of the first. They were a separate people with different origins, who likely found the islands sparsely occupied or already abandoned. Two waves, two stories, layered across time, yet only now disentangled through ancient genetics. One of the most striking findings from the genetic analysis was just how little the two populations mixed. Out of the few individuals with usable DNA from the later Lucayan period, only one or two showed even a trace, about 10 to 15%, of ancestry from the earlier archaic settlers. This suggests the two groups were culturally and socially distinct. Whether separated by centuries, geography, or intentional boundaries, they did not significantly intermarry or merge. In the Bahamas, the arrival of the Lucayans was not a gradual blending, but a replacement, with the memory of the first islanders nearly lost, until now. To sharpen the picture, scientists turned to mitochondrial DNA, which is passed down through mothers, and Y-chromosome DNA, inherited through fathers. The archaic individuals carried mtDNA haplogroups like D1 and C1d, ancient maternal lines found in early Central and North American populations. In contrast, the Lucayan samples showed haplogroups like B2 and C1c, common among later South American and Caribbean farming groups. Y-chromosome markers told a similar story, with distinct paternal lines separating the two waves. These lineages acted like ancient signatures, confirming what the broader genome already suggested: two peoples, two migrations, and two separate chapters of Bahamian prehistory. These discoveries are reshaping how we understand the history of the Bahama Islands. For years, the narrative focused almost entirely on the Lucayans, seen as the first and only pre-Columbian people to inhabit these islands. But now we know that the Lucayans were just one part of a longer, more complex story. The earlier archaic settlers, though largely forgotten, were skilled navigators who may have island-hopped across the Bahama Bank, linking Florida, Cuba, and the Caribbean in ways we're only beginning to appreciate. Their brief presence suggests that the Bahamas were not simply remote outposts at the edge of Taino expansion, but active maritime frontiers with multiple waves of human movement. These findings also change how we interpret other early Caribbean sites. Perhaps similar overlooked populations reach the Turks and Caicos, or even Bermuda. With every genome sequenced, the Bahamas become less of a historical backwater and more of a crossroads. Despite these breakthroughs, the Bahama Islands still hold many unanswered questions. Ancient remains are rare, and many promising sites lie in hard-to-reach caves, underwater sinkholes, or eroding coastlines. Future excavations in places like Abaco and Long Island could reveal earlier burials or campsites. Researchers also hope to find signs of ritual life, early canoe routes, or evidence of contact between the archaic settlers and later Lucayan arrivals. Could traces of those first voyages still lie buried beneath shifting sands? Only with more sampling and closer integration of archaeological and genetic data will we uncover the full story of the island's earliest people. The Bahama Islands were never just quiet outposts waiting for Lucayan canoes. They were visited by earlier travelers whose presence we're only now beginning to recognize. Thanks to ancient DNA, a forgotten wave of archaic seafarers has re-entered the story, reminding us that history is often deeper and more layered than we imagined. So what other lost migrations are hidden beneath the sand and sea? Let me know in the comments what you think about this forgotten chapter in Bahamian history. If you enjoy these explorations of ancient lives and distant pasts, check out the Patreon, and don't forget to like and subscribe.